Welcome back. So there's one more law that we have to discuss. And this one is going to be Dalton's law of partial pressure. This one is super easy to understand. So let's do it right away. What is Dalton's law of partial pressure? Well, if I tell you that 3 plus 4 plus 1 equals 8, would you believe me? Let's double check it. 3 plus 4 is 7, 7 plus 1. Yeah. So that's the law of partial pressures. It basically tells you that if you have a container that contains a gas and the gas on it happens to have 2 atmospheres of pressure. So let's say that you have this many moles of the gas, and that's 2 atmospheres of pressure, and you have another gas. Imagine the container is exactly the same, and then you have your gauge with 6 atmospheres of pressure. And now imagine you have another container the same size with another gauge and on that container you put that gas, and you also put the other gas that you have in there. So when you put all those together into an equal size container, then your pressure is going to be 8 atmospheres of pressure. So that's nothing more than this one is 2 atmospheres, this one is 6 atmospheres. So when you put it together, it's going to be just adding them. That's what the law says. So there's no attraction between the gases, because that's what the kinetic molecular theory tells, that on a gas the particles are so far away that they don't interact. So by having different type of particles there, it doesn't affect the pressure of each one of them individually. So the gases, the original pressures, as long as the container is the same size, all you have to do is add the pressures to know the total pressure of the mixture. That's what the law of Dalton, or the Dalton's law or partial pressure says. So an example would be like this. So we have a mixture. So we're always dealing with mixtures, more than one gas together. We call this one heliox. It's used for diving into deep sea water. And this one contains oxygen with a total pressure of 0.30 atmospheres. For the oxygen, the contribution of oxygen is 0.30 atmospheres, but the whole mixture is 11 atmospheres, and the mixture is oxygen and helium. So it's basically telling you that the pressure of oxygen plus the pressure of helium is going to be the pressure of the mixture, which is going to be the total pressure, which is going to be, on this case, 11.0 atmospheres. So the question is, what is the pressure of helium? So since you know that these two are going to be 11 atmospheres, and you know that the oxygen is, let me do it, so 11.0 atmospheres, and you know that the oxygen by itself is 0.30, then the difference has to be the pressure of helium. So the pressure of helium is going to be 10.67 because the pressure of oxygen plus the pressure of helium equals 11.0 atmospheres. And you know that this one is 0.30 plus that equals 11.0 atmospheres. So that's how we use the Dalton's law of partial pressure. The pressures are going to be additive, so you know exactly how much each one of them contributes if you know the total pressure. So using that knowledge, can you do this problem? Some hints on this problem. You have 3 different gases now. The total pressure is given on millimeters of mercury. 2 of the pressures are given. And you're supposed to find how much the oxygen is contributing, but you need to find it in atmospheres. So you know what you need to do. That shouldn't be a hard problem for you. And once you do that, we can say that you truly understand the law, the Dalton's law of partial pressure. When you have a mixture, the pressure of each one of the components is a partial pressure because it's not the total pressure, right? So this is going to be a very short part of the lecture. So when we come back, we're going to close the chapter by talking about stoichiometry for gases. Remember theoretical yield, percent yield, limiting reactant, and all that. For us to be able to do all that, we needed first to be able to do mole to mole conversions. So we're not going to be doing specifically limiting reactant and all that, but you are going to be doing basic stoichiometry with gases. And remember, every time we do stoichiometry, it has to be moles. And if we're dealing with a gas, we have this formula, so it doesn't matter what. If you're doing stoichiometry, you're going to have the moles. So that's all we're doing. Given the properties of gases, pressure, volume, moles, and temperature, can you find how many moles you have and then do a stoichiometry like you will do with grams or anything else. So that's what we're doing when we come back to this part. So for right now, we're going to leave it there, understanding the Dalton's law of partial pressure. So until the next time, see you soon. The next one is going to be a little bit longer than this.